I'm going to do a little quick talk about control structures and kind of how they play into the database app server relationship and kind of some of the cool things you can do with them, and show you a few examples along the way. So first quick kind of preview of who am I? I'm Michael, although most people call me Mike. I'm a founder and CTO of Native. We do social optimization, and I have lots of side projects, and I find them very fun. Most recently, I'm building this side project that's basically a notification center in your app, powered by RethinkDB. It's kind of my first foray into Rethink, and kind of explored all these different edge cases and uses that I've found super interesting over the last probably 6 months or so. And I've started using it since version 2.0, so if there's anything I say that is not version 2.0 friendly or stuff like that, quick little caveat there. So what are control structures? Control structures are basically ways that you can extend the functionality of your queries to your database by allowing you to do more complex things. And Rethink kind of brings a very unique approach to this in that it's obviously built on dynamic languages. So you can really do dynamic features and stuff all from within your app servers. If you're coming from a MySQL background, you'll know that there's these things called stored procedures, which are basically like you submit them to your database and they can run them, and they're very fixed and controlled in what they do. Whereas RethinkDB is at least a JavaScript driver, is extremely functional, and you can compose these queries, chain them together, and then when you run them, you submit it all to your database. It will evaluate all of them in sequence or whatever you want to do, and then return you the results. So instead of like doing all these round trips back and forth from app server to database and back and forth, you can kind of make it very easy to use and maintainable and readable code, which is very nice. So I'm going to go through 3 control structures here. There's looping, branching, and my unsung hero is HTTP, and kind of share a few little examples of pretty easy level things, but they got me hooked. I came to RethinkDB because of the change feeds, and I actually stayed for everything else. I actually have never used the change feeds in any of my code that I use, but it's still a sexy concept, and hopefully one day I can get there and use it, but I've stayed for everything else, which is a testament to kind of what it can do. So looping, what is it? It's pretty simple. You can kind of like go through documents and perform functions on them, iterate through them, sum them, do all sorts of things. And I'm going to go through a quick example. For all my examples, we're going to kind of have a little universe. Who's excited for Star Wars? I know I am. So we are going to be in the Star Wars universe. And so there'll be a lot of examples there. So imagine we have a dictionary of people, and we are trying to figure out, all the pilots who can fly these different starships. Some people can, some people can't. As our database has grown and grown and grown into these huge things, we might want to denormalize that relationship. And so for eaches are a really easy way, although not the fastest, but definitely the easiest way to kind of go through and denormalize that relationship. So if you look through here, we can start with the starships table and go, okay, for each starship, let's find all the pilots who can fly them. And for each of those pilots, which is an array, we are going to go through and update each of the people and mark them as a pilot, right? So this is all executed on the server here, even though it feels much like what you'd write in any sort of Node or JavaScript context. You have your same kind of for each things. You have your lookups, pretty much near exactly what you'd write on a regular operating code, but yet it's operating entirely within the context of your Rethink server. So let me just bring up, wrong one, this. And so when you run this, it'll actually go through and it will say, hey, we have 19 newly declared pilots. And then the first one it spit out was Luke Skywalker, who obviously flies his starships around. And so you can just denormalize that relationship, and now you can look up pilots where pilots equals true without having to go through the whole double lookup step. So it's significantly faster and very easy. One kind of caveat here, as if you want to do this in production, is that it is non-atomic and streaming in that regard, so you can do large sets of data. But that being said, if you insert a person who's potentially a pilot while this thing is running, they may or may not be updated. So just a word of caution there. But knowing that in advance, it's pretty easy to work around. A million ways of doing it. Cool. Branching. Branching is essentially the if-else operator in any sort of kind of control structures, programming languages in general, and it's extended through to the database as well. And this provides you some really cool techniques to kind of like compute stuff on the fly, whether or not you want to update something or query something or do even more advanced things. It gives you this really cool operator to do this. So in this example here, we have a little drone that's flying around through deep space, and it goes through and scans all of the planets, and we kind of want to keep a running track of when they were last updated. And so basically, instead of, let's say, having this drone, right, with like millions of light years away, having it kind of talk to our home base, do what it needs to do, and then go talk to another remote server to update it, we can actually just use branches to do it all on one server and then get the response back without having these round trips back and forth. So here's kind of the query, and I'll kind of talk it through. So for our tables planet, we were trying to find the ID of the planet, and we replace it. And here's the magic, the branch here. And what we do here is we say, is the document equal to null? So null will be returned here if we have no planet of that ID. And if the planet does equal null, we'll insert the data whole hog straight in there. Otherwise, we will take the existing document and merge the edited field with the new date time, which is now. So we can leave all the other fields intact. We can see like when the first, when it was created, and leave all that exactly where it is without touching any other fields, and perform that all within the context of the database server. So let's give that a quick run real quick. Node branch.js. So you'll see here, as we fly by Tatooine here, it actually updated the edited field, which is right here, while leaving the created date in place. Whereas our new planet, it both created and updated and edited with the newest data. So it's pretty simple. One other cool thing, kind of like in that context of thinking in that context of everything happens on the server, r.now is actually evaluated on the server as well and is the same date time uniformly on the entire query. So you don't have to worry about like millisecond differences or anything like that. It's just r.now will be exactly the same as it's executed. As you kind of look here and you see this branch, one kind of thing that threw me off in the very beginning that I had to get used to was that this equality operator here is also not done within the app server itself. So when you're doing it, there's a whole slew of like less than, greater than, all sorts of different kind of equality checks, but you have to use the rethink equality checks and not just some arbitrary equals equals or less than within the context of the app server, because it's not run there. So it is kind of a big paradigm shift when you're thinking about how to execute and architect queries. And once you kind of get into this really cool philosophy, it's much more powerful, much less bouncing around, especially in the async environment when features are bouncing around. It's much easier to really just think about it in one whole batch query. HTTP. This is kind of like the little hidden gem that I've always found super cool, and there's like a million different use cases for it. But basically, it gives you a whole hog like HTTP driver and to do in many different ways. A lot of different ways is downloading data and kind of just like playing around with it. You can kind of use the rethink query language to query like Reddit. Reddit, you can pull in like if you add .json to any URL, it'll give you all the JSON, and you can play with it what you want. And you can do all sorts of different things with it. You can download data sets and bring them in from third-party services. And you can kind of like extract, transform, and load it into your database, and then query it as much as you'd ever want to do. So it's pretty nifty. One of the other kind of like cool side effects of this is you can also post to services as well. And if anybody's kind of familiar with like the whole like microservice movement and what that entails, you can actually do a post request after a query. So in this example, right, imagine we have our same drone who's flying around the planets, and they're scanning people and inserting them to this person database that we're trying to collect to keep track of whatever. The Imperial Army comes in and they're like, hey, we want you to send us every person you scan. So basically, what instead of having to insert into our database and then adding some extra lines in our app server to say, hey, after the successful insert into our database, let's post to some other service, we can actually do this within the whole context of Rethink. So here, right? So you have me, it scanned me, and we're going to insert me into the table, and we're going to return the changes here. So what return changes does is it will not only just insert it and give you the generated ID, but will actually give you the old and new value, which in this case the old value is nothing, and the new value is me. So and then do, which is kind of like this really fun operator. It allows you to chain things together, and it will actually pass the first query into the argument of the second function there. So basically what we do is we're saying do this second part of it, which is a HTTP request to our microservice with the method post, and the data is the doc.json. So pretty simple here. You can just take the query, insert it in, and pipe it right through. So if we node. So here you can see exactly what happened. We successfully reported it, and this is the exact kind of feedback of the HTTP post that went out to that service. You'll see that it has the user agent of RethinkDB 2.0.0.1 because I haven't updated my system in a while. But yeah, you can see all the fields, the birth year, created times, edited times, as well as like replaced, inserted, updated, and all that stuff, and you can kind of map and change and pluck fields and do whatever you want to do. But in a nutshell, you really can just take whatever you want to do instead of like having to take it back onto your server, do all this different manipulation. You can just do it all within the context of the ReQL language. Because of like all the really hard work that's been put in by the people who wrote the drivers, and thank you very much, they're fantastic. It really makes it really easy to read and maintain. And you can get code like this and be able to have it in your data, have it in your app servers, be able to read it, understand it, change it if needs to be, and have the power of it having to be within the database itself. Overall, I find it to be 100% awesome and really helps like in breaking down that barrier that I feel sometimes is a little too rigid between the app server and the databases. And when you kind of meld it a little bit, and with great responsibility comes with great power comes great responsibility, but at the same time, you can really do some pretty amazing things. And just a quick little recap there, and that's pretty much about it.